हाँ संदीप,
This is
हाँ यस यस,
this is VK
वी कैन हियर
Parashar
यू।
from BSN.
जी पराशर जी, अभी थोड़ा सा
Sir, I
सेट कर
just
लेने
want to.
दीजिए।
हाँ
पराशर
हाँ
जी
सर, मैं तो
प्लीज
एक्चुअली
होल्ड ऑन,
उसके लिए पूछ रहा था, ये जो हमारा एवेल्युएशन है ना सर।
थोड़ा सा होल्ड कीजिए, थोड़ा सा होल्ड कीजिए।
राइट सर।
संदीप,
ओके सर।
हाँ संदीप आपका माइक म्यूट है, अगर आप अनम्यूट कर पाए। संदीप आपका माइक म्यूट है। माइक यहाँ नीचे दिख रहा है ना, आप इस यहाँ से भी कर सकते हैं, जहाँ लिखा है ना इंग्लिश, और जहाँ पे ये साइन आ रहा है वहां से भी क्लिक करके कर सकते हैं। यहाँ पे हाँ हाँ यस,
Now I
इट
think
इज
okay
ऑन
ना
नाउ।
sir?
हाँ हाँ अभी आ रही है, आप पीपीटी में चले जाइए। यस ओके, सो बिफोर
Okay.
यू स्टार्ट मिस्टर पराशर वाज वांटिंग टू से समथिंग। पराशर जी प्लीज गो अहेड।
यस सर, एक्चुअली मैं तो वो एवेल्युएशन के लिए पूछ रहा था सर, कि जैसे एक जो क्विज है, इन दैट क्विज मार्क्स आर बिलो व्हाट इज रिक्वायर्ड, so now how
So
to
don't worry, we will take care
improve
of
it.
that. So have you attempted all other quizzes?
All other quizzes except for one, this QIS only.
So don't worry, don't worry, don't worry. We'll take care of that.
Yes.
Okay.
And
We
this
consider that.
synchronization quiz was not having any end time, right sir?
Maybe I missed it. So including the timer, but you please attempt and
Right
submit
sir,
it.
that I have already attempted sir.
Great.
Thank you sir.
Okay.
Thank you.
So over to you, Sandeep. I think we have taken
Okay.
your half an hour
Okay.
time
Thank you.
in the
Thank you
previous
sir. Thank you.
discussion.
Should we start now, na?
Yes, please. Yes, please.
Okay. Thank you sir. Today's session in this course is regarding 5G call flow in the both mode, that is the standalone mode as well as in the non-standalone mode. And what is the agenda today? And first we will discuss the what UE measurements done during the idle mode or dedicated mode, and why it measures the different RSRP and RSRQ like that. Then we will discuss the random access procedure and RRC connection management, and then standalone basic call flow and non-standalone basic call flow. Right. So first slides, it shows the what UE actually measures in idle mode as well as in the dedicated mode. So there are two things. Measurement item is there, that is the SS block, you can say, or SS by PBCH. Second one is the CSIRS. These are the two, you can say CSIRS is the reference signal, channel state information reference signal. The CSIRS actually allocated to the user specific. It is only allotted to the connected UE, not in the idle mode UE. And SSPBCH is measurement is done in the idle mode actually. This is the coverage verification SSB block that I have studied in our previous session. The measurement done on the basis of per block SSB block basis, and also per cell basis, and also BCCH index basis. Likewise, CSIRS, it also measured CSIRS. Let me use the pen. CSIRS resources that is allocated to the particular UE actually in the connected mode, and it is measured per CSIRS resources and per cell based resources and CSIRS resources measurement identifiers like CRI beam that have discussed earlier. So first things that UE measures the coverage beam like SSB blocks in terms of three things that is written here, the SSRSRP and SSRSRQ. SSRSRP, actually what it measures? Actually, what is this SSRSRP? It is the synchronization signal. In this block, you can see here in the SSB block, there are four symbols. Four symbols. PSS is the primary in the time domain in SSV log, there is 4 symbols. First symbol is the PSS, that is the primary synchronization signal. And second symbol and fourth symbol is the physical broadcast channel. And in between the second symbol or third symbol, it is a secondary synchronization signal. So actually, this SSRSRP is a measurement of the average power received from a UE from that second synchronization signal only. It is the average power per resource element. Average power per resource element. That is the SSRSRP. What UE actually measure, and this measurement actually done for the calculation of the timing advance, path loss between the base station and the user equipment, and all other mobility parameter like cell selection and power control calculation. These are the techniques, mobility management, everything na, for handover purpose. The measurement is done. Second is the SSRSRQ. What is the SSRSRQ? SSRSRP is the measurement of average power received by UE from this secondary synchronization signal. SSRSRQ, you can see here in the formula, na? SSRSRQ equal to SSRSRP that we have received divided by RSSI divided by N. What is the RSSI? It is the received signal strength indicator. What it means, actually, the RSRP is the just calculation of the received power from the secondary synchronization signal, but RSSI is the measurement of all the symbols in that domain, in that OFDM symbol, means third symbol. All the resource block having the symbols like PBCH and all the DMRS and triple Rs or PDSCH, every channel that is allocated in the whole bandwidth or our particular resource block, they measured all the channels, not only the triple S, or we can say the secondary synchronization signal. That is the RSSI and divided by N, because we are calculating the received signal strength indicator per resource block. This one is the RSSI, received signal strength indicator, and is the number divided in resource total resource block. That means it is a received power per resource block. Right. This one is the SSRSRQ. Actually, SSRSRP provides the path loss between the user equipment and base station G node B, and SSRSRQ provides the loading in the network. And third one is the SINR. So SINR, basically it measures the interference with respect to RSRP. It measuring the interference. Actually, secondary synchronization signal having the same frequency time domain in nearby cells. That's why a high interference is there. In the 4G, all the resource element for the CRS, and it is a different for different cell based on the PCI, physical cell identity, where there that there is a no interference. But here the secondary synchronization signals locations of this SSS is almost same in the nearby cells. This is basically SINR calculates the interference in respect of SSRSRP. Second main measurement of UE measurement is the CSI RSRP. Always CSI resource element provided to users only when they are connected. when they are RRC connected, or they are doing some data transfer, user traffic transfer between the UE and network data network. The CSI reference signal receive power, it also represents the average power received by the allocated reference signals to the CSIRS. The CSIRS reference signal allocated to UE only they are connected. It is absent when the UE is in idle mode. CSIRS RQ in the similar fashion, it also represents the loading, or the CSIRS RP divided by the received signal strength indicator per block, right? And the unit of this CSIRS RP, it is a dBm because it is the absolute power. And CSIRS RQ and CSI SINR, it is a reference power. That is it is a relative power. That's why it is a unit of this CSIRS RQ and CSI SINR. It is the dB one. In both cases, SSRS RQ and CSIRS RQ. And CSI SINR also represents the wanted signal to the interference plus noise power. It also the interference with the respect of only the CSIRS reference signal. This slide shows the initial procedures, how the PLMN selection and cell selection. That's a basic how the PLMN selection is done by the UE. Actually, in the UE in the broadcast message, a PLMN list is already there. By choosing the PLMN list, preferred list is there. There may be one PLMN list. There may be more than one PLMN list by subscribed by the UE. So before choosing a suitable cell, the device must first find the PLMN. Then cell selections. Cell selection means in which system information block say cell selection.
Sir, your voice is breaking.
Sandeep, you can mute your video so that uh, I mean your voice is heard by everyone. So can you just mute your video, or maybe we can try from here. Yeah, yes. You can just mute your video portion. Yeah, thank you, thank you.
Now it is okay, sir.
Now it is okay. Go to the PPT.
Thank
Yes,
you.
it is much better.
Just
Yeah.
like a cell selection in the LT, here also in the 5G, the cell selection criteria is there for with respect to SSRSRP and SSRSRQ, right? There are minimum level defined for RSRQ and RSRP. The difference between both of them, received RSRP and minimum, that is the criteria for the cell selection that is defined in the SIB1 message that is broadcast by the G node B to the base station. They compare both. If they are greater than 0, then the cell selection is happen, otherwise cell selection will not be. And this criteria is very similar to in 4G, or it also very similar to in 3G also. And after that, there is a radio connection that we will discuss in the detail. Downlink synchronization, RRC connection, and then the call flow between the NSA and non-NSA. In the release 15, in the 3GPP release 15, actually what the measurement for cell reselection actually for cell reselection parameter, the 5G actually broadcast the SIP2 information. SIP, system information block 2. In that SIP2, actually the cells reselection measurement requirement remains the same. What is the cell reselection measurement? That means serving plus neighbors of 5G, their RSRP and RSRQ, they measures, right? And depend on the threshold defined, they select the cell, and that measurements reports on the periodically to the UE, send the periodically to the base station. In the 3GPP release 15, actually cell reselection measurements requirements remain the same, whether the movie UE user equipment is mobility mode or it is a rest mode, whether it is a cell center or whether it is a cell edge. There is the same parameter measurement is same. They are measuring always time to time, and they are sending to the G node bit. And what impact of this? The same measurement rules for all the UE, whether it is a cell edge or cell center, whether it is a mobile or it not is a mobile. It drains the power of the cell. It drains the power of the cell, means mobile equipment. But in the 3GPP release 16, they have make certain arrangement, that is the relaxed resource RRM, radio resource measurement, for the idle and inactive UE. Actually, cell reselection is always done for idle and inactive users only. And handover procedures performed only for the active users or or users which are connected to the base station or the network, right? So the cell selection and reselection is always performed by the idle and inactive UE, and handover is performed by the active UE, that is connected UE, we can say. So in the relaxed radio resource measurement, first, the cell reselection measurement are relaxed for which they are relaxed the users equipment, that is the reside in the cell center and or they are low mobility, right? For that users, the measurement reporting period time is relaxed. They are not sending every time, measuring the every time and send the measurement report. It actually saves the battery life of or battery of the user equipment or 5G mobile. And how they evaluate the users is idle or user is mobile or user is the cell edge or whether user is a cell center. It is based on the some criteria, based on the some threshold of
Sir, your voice is gone.
I
Sandeep,
think
if you can
mic
check
is
your, now it is okay. Yeah.
okay.
Acha, mic had gone. Okay,
Okay.
now it is okay. Go to the PPT. Yes.
Okay, sir. If any question, first part of our presentation regarding the UE measurement is over. What basically UE measures in the idle mode as well as in the dedicated mode. If you have any question, then please ask. Then we move for 1 to 2 question quiz. Yes, please.
Sir, in this measurement reporting by UE,
Yeah.
can there be option for network to page for the location of UE and then accordingly ask him to change the cell or carrier? Like say, sir, in 2G there were two methods were there in which the UE was telling I am here and location and other measurements were conveyed to the BTS. But at the same time, there was a provision where the BTS or I say E node D will be paging for the UE whether you are still there or you have moved somewhere else. Is that kind of provision exist in the 5G?
Paging is the different concept now. When there is a active call, yeah, data comes for the UE, incoming data comes towards the UE. Then paging message actually, we will discuss one slide how the paging done. The UPF notify the SMF, then SMF notify the AMF, and AMF broadcast the paging message for the connected UE or idle mode UE. And
Okay.
second one,
I think Chaudhary Saab is asking about the update,
acha,
periodic
location
update,
update.
location update, mobility update,
Location
by
update.
which
Location
you,
update.
yeah,
Right, sir. Right. I understood now. The location update now in the 5G, that is the registration area update is there. And instead of location tracking area in our GSM, that is the location area update is there. But in the 4G, that is the tracking area update. Location is the MME know the UE location in terms of the tracking area. But in the 5G, the AMF save the location of the UE in terms of registration area. There is a periodical timer is there for periodically check the whether user is present in that registration area or not. There is a timer there for 2G. There is the timer 3212. For 4G, there is a timer for 3412, and for 5G similar to timer 3512.
Okay, sir.
Right.
Okay, sir. Thank you, sir. Thank you, sir.
Okay. Should we move the quiz? One or two quiz for this section. SSRSRP. What it represents, the average power received from the single resource element allocated to which of these? Secondary synchronization signal, primary synchronization signal, SSB synchronization signal block, and broadcasting. So you can actually, I am not able to see the chat box now. So you can unmute
I
yourself.
can read for you. Sandeep, I can read for you. People are answering secondary
SSS.
synchronization signal. We have got lot many answer by many of the participants.
Okay, sir. The answer is correct. That is the A. That is the secondary synchronization signal. That measurement is used in the idle mode. Second question is the CSI RSRP measurements are used by which UE? Idle mode UE, connected UE, not registered UE, none of them.
Connected UE.
Ideal UE.
Ideal UE.
That is the actually CSI RS reference signal always allocated to the connected UE. Always resource element for CSIRS is allotted for the connected UE only. That's why they measure only the CSIRS is measured only by the connected UE. CSIRS resource element is not present in the case of idle UE. If there is no UE in that cell, there is no CSIRS is allocated by the G node B for any users. Okay, sir?
G.
Now, 5G basic signaling procedure. What are the different signaling has been done before the data transfer from the UE to the DNN? 5 or 6. This one is the basic signaling. First one is the system information broadcast. G node B broadcast the system information to the UE in terms of MIB and SIB, master information block and system information block. And second signaling is the paging, that you have told the when there is a network needs to set up a connection with the UE. Not UE needs to set up a connection with the network, but when the network needs a connection set up with the UE, the network initiate the paging procedure to locate the UE. Right. And third is the random access procedure. Random access procedure actually starts for the uplink synchronization, and also some messages used for the RRC connection setup. We will discuss detail this random access procedure and RRC connection setup between UE and G node B. And then context management. What is the context management? For every connection between the UE and G node B and G node B to the AMF to SMF. For the UE, they create a ID, UE ID in terms of NGAP ID, and GAP ID. AMF create the NGAP ID for the UE. They are not always sending the data or any message from AMF to SMF or AMF to G node B by sending the SUPI or SUKI. They create the identity for that. That is the UE and GP ID. All the node create the ID for the particular UE. They have the connection. The different UE ID for different UE. That is the context management. And last is the PDU session management. A PDU session is a data connection. It is just a logical connection between UE and the DNN, right? For the transferring the data from the UE to data network and data network to. And this one is just a overview of how the master information block and system information block is transmitted from G node B to the master information block. That is the message contains the system frame number and all the what bandwidth they are supported, right? That is the MIB. They are on which channel they are getting broadcast channel, right? And there is in this master information block, there is a address of the SIB1. That is the cell selection criteria and all the RAG procedures, parameters, all they have in SIB1. And the address of the SIB1 which have, that is the MIB have the address of the SIB1. And the all other SIB message like SIB2, SIB3, SIB4, SIB5. Some message are the periodic, like SIB2, it is the cell reselection parameter. It is a periodic measurement report is sending by the UE. That is the periodic, and some is the on request basis. When the system information request for the measurement, the actually system information message is sent by the G node. Paging, this slide I have taken from the empirical. The paging actually when the your network is wants to need to connect with the UE, that when the data comes to the UPF, then the UPF notify the SMF, concerned SMF, so that it turns notified to the AMF. The single point, actually G node we have a single point of contact to the core network in the control plane, and UPF is a user plane single contact point that G node we connect with the core network in the user plane, that is UPF, and for the core network control plane they connect with the AMF. So UPF notify the SMF for downlink data, and then SMF send this notification to the AMF, right? And then AMF sends the paging request to all the G node B within the tracking area. Right?
Sir, this paging, sir, this paging, can it be used for
tracking area? Actually, in the paging in the LT, there is a tracking area code, and another one is the tracking area list, or we can say MME pool is there, tracking area list is there. A group of tracking area is known as the tracking area list. The tracking area list is very similar to registration area in the 5G. But tracking area is always there present in the 5G also for the paging purpose. Why they make the registration area? To avoid the overload of signaling. We are not, if we move from one tracking area to another tracking area, they are unnecessary. Taking the registration area update, it uses the lot of signaling at the radio resource side.
Okay. Okay,
to
sir.
reduce this. Okay. The G node be actually AMF send the paging request in the tracking area. They are sending all the base station G node B to the tracking area, but with what? With the temporary ID that is allocated already by the AMF. Which of the temporary ID? There are two temporary ID, 5G GUTI and 5G TIMC. The 5G TIMC is a shortened form of the 5G GUTI. So 5G TIMC generally used for the paging purpose because of it is a shorter message that increase the paging capacity also by the G node B. So when where the UE suppose there in this G node B, then transmit paging message transmit in all the tracking area, but respond only by the UE that have the notification actually in the form of paging.
Sandeep, over here you have hello, am I audible?
Hello, please.
At the last slide, at the point number 2, you have mentioned that the UPF only notifies to the SMF of the downlink data. Is it possibility that we do have the different SMF for the different channel of data? Likewise, one SMF for the downloading one.
Different SMF actually are created for the different network slicing.
Okay.
If you are go to the network slicing now, there are URLLC and MMTC or EMBB. Different SMF is there for different.
That's quite okay, but whenever we are whether we are going to employ the URLC or the MMC type of the communication, there is no such issue. But exactly in that particular case, one SMF will take care about the download as well as the upload. Both the channels would be taken care by a single SMF, I guess.
Download and upload. Actually, SMF is a control plane functionality.
Yep,
right.
correct.
Session management. It handles only the session management related functions. And this one is the UPF is a user plane related functions. If user plane and control planes are totally separated in the 5G. When they are communicating UPF with the SMF, there is one protocol that is the PFCP protocol, via which, or we can say interface is the N4 interface. N4 interface is used to transfer the message between UPF and SMF. Right. And different SMF is there for session creation and session modification and session deletion or session initiation. So first, all the incoming message when they are come in the UPF, they notify to the SMF only. And the single point of contact of radio access network to the core network in the control plane, that is the AMF. Correct, Alok?
No issue.
Okay. Here you can see how the different signaling procedure from UE to when they are power on and up to the data exchange. First is the PLMN cell search procedure, the synchronization, downlink synchronization by using the PSS and SSS, right? By using this PSS and SSS, they also the evaluating the PCI of the cell, right? And after MIB, there is the master and system information. MIB is there in the broadcast channel. They are transmitted towards the UE. And after reading the MIB message, they know the address of the system information block 1, where all the RAG parameter and cell selection parameter is there. And after reading the parameter cell selection, they select the cell and using the RAG parameter, the procedure for uplink synchronization happen at this stage. And after RAG procedure, there is a signaling connection between the UE and G node B. And that after the connection is set up, RRC connection set up, there is a registration in the 5G. Registration, in that registration process, there's a authentication is also is there. Authentication, authorization, all these happen in the this registration process. After the registration, there is a PDU session establishment between UE and core network and core network to the external data network DNN. After PDU session setup, they exchange the traffic between UE and DNN or UPF events. This is the overview of just the top of the all how the traffic moves, signaling and traffic user data moves from UE to core network and then external data network. Now the random access procedure. After the downlink synchronization, after the SIB1 message, reading by SIB1 message, they know about the RAG parameter, which RAG parameter they use, right? There are 4 steps in the random access procedure. And there are 2 types of random procedure. That the first one is the contention based RAG procedure. Second one is the contention free random access procedure. And one additional random access procedure is given in the 3GPP release 16, that is the 2-step random access procedure to reduce the latency, to reduce the control plane latency. In this random access procedure, you can see here the message that transmit by UE in the Zebra random access procedure. What is the message contains? When the send the RAG message, it contains the rapid, that is the ID of the preamble, random access preamble that is sent by the UE. Okay. Second one is the random access RNTI. That is the identity of the in which domain, frequency, and time domain resource they are sending. Okay, and also it send the establishment code. They send to the RAG. That is the first message. And G node B, and on which channel, physical channels they are sending. That is the PRAG, right? And the G node B respond the rapid on RARNDI by message 2. Okay, by measuring the their signals, their random access sequences, you can say. They are sending in the random access response. This message 2 is known as the random access response, RAR, and in which there is a temporary cell RNTI. This one is the radio access network identity used, right, for the connection in the signaling process. First one is the temporary CRNTI. After the contention resolution, they gives just a CRNTI, not a temporary CRNTI. Timing advance and uplink grant channel. This RAR is message sent on the PDSCH, physical downlink shared channel in the downlink direction. After the scheduling grant channel, right, they are sending, actually they are allocating the PUSCH resource block, not resource block, actually the control channel element that is used for the CCE. They are allocated G node with CCE for the uplink for the mobile. They are sending the CCE in the PUSCH channel. And it is a set up a request on SRB 0. This is the signaling radio bearer are created. That is the a common control signal, common control channel. Two types of signaling there. There is a common control signaling and dedicated control signaling, dedicated control channel. And after that, the SRB configuration, depending on the configuration, they send the message for RRC setup. That, or we can say contention resolution. This message is also, message 4 is also known as contention resolution, is sent on which channel? That is the PDSCH channel. That is also sent on the this SRB0. SRB0 means that is the resources allocated by the G node B, that is the control channel element, CC element message there. So this 4-step is the random access procedure used for uplink synchronization by the UE with the G node. Second one is the contention free RAG procedure, where the sometimes in this procedure G node B actually allocate the random access procedure. In the previous version of random access Cibra, they randomly, actually their UE is selected randomly preamble, but here in the contention free random access procedure, G node B allocate a random access, this message, random access preamble, and then the random access preamble, those random access preamble transmit by the UE to the J node B, and random access response, similar message 2 is sent by the G node B to the UE, and the scheduled transmission in the random access response. There is no need of contention resolution message 4 in that type of CFRA or contention free RAG procedure, because they are already provided the preamble. G node B already provided the preamble to the 5G user code. Four-step random access procedure I have already discussed. CBRA and CFRA, random access preamble, random access response, second message, third message is the scheduled transmission, and fourth message is the contention resolution. But in 3GPP release 16, they are also give us the two-step random access procedure for reducing the latency at the control plane side, where the two messages there, the first message is the message A, and second one is the known as the message B. In the message A, they are sending the preamble and also the PUSCH load, payload. What is the PUSCH? Actually, it is a message 3. This PUSCH load is already informed to the UE via SIB1 message, SIB1, System Information Block 1 message. All right. Then from the message B, they are sending the success random message response or contention resolution ID that's sent in the by G node B to the UE. That is the two-step process only to the reduce the latency in the control channel. It is not the case that there is the 4-step or 2-step only. There is a case by case, or you can say by the, if the 2-step RAG procedure somehow fails, they are not sending the or decoding the preamble or PUSCH load, they starts changing from 2-step to 4-step random access procedure. Now the RRC connection setup procedure. Previous one is the random access procedure. If you have any question regarding the random access procedure, then please ask. Then we will move towards the RRC connection setup. Am I audible to all now?
Yes, sir. You are audible.
Okay, sir. Now the RRC connection setup. It is a three-step process. First one is the message 2, message 3, and message 4. These two messages already in which in a RAG procedure. The message 3 and message 4 RRC setup request is already sent on the RAG procedure, and RRC setup is also sent in the by G node B in the RAG processor. RAG procedure. And one extra message that comes in the RRC connection setup. It is a three-step procedure. RRC connection setup is a three-step procedure when the UE informs to the G node B. UE informs to the G node B for the RRC setup complete message. This third message, that is the RRC setup complete, on which signaling radio bearer, that is the 1. This one is the dedicated control channel. This SRB 0 is the common control.
Audio lost again, please.
Sir, audio is not there, sir.
You are not audible, sir.
Some gap in Sandeep, can you check your connection?
1 minute, sir. We should, I think, connect with our phone, na?
Yes, sir. Some gap is there, sir. Audio. I think it is now audible. Can someone else also confirm?
Yes, sir.
Yes, sir. Yes, sir.
Yeah.
Audible.
Go ahead,
Yes, sir.
Sandeep. Sandeep, go ahead, please.
Okay, sir. Now I am audible, na?
Yes, yes.
Okay,
Yes,
sir.
sir. Yes, sir.
The RRC connection setup is a three-step procedure where two messages I have already discussed in the random access procedure. Third message, that is the RRC setup complete, that is sent on the SRB1, and SRB1 is a signaling radio bearer. It is a dedicated control channel. That is dedicated control channel. SRB0 is a common control channel. And this actually dedicated control channel, actually it have the of like RLC, RLC unacknowledgement, where the retransmission is there for error correction and detection. But SRB0, such types of facility is not there. It is a transparent mode transmission. And this RRC setup complete message, actually this sent old 5G GUTI, or you can say 5G Suki, na? Subscriber concealed identity. If their first time UE power on, they are sending Suki. Otherwise, they send the 5G GUTI. This fourth step of RRC setup complete message, it is a registration request. We will discuss in the call flow of 5G that is the registration request by sending in the 4G and 5G. One difference is there in the RRC setup complete message. They are sending actually for in 4G they are sending for two types of message. First one is for the attach procedure. In the LT, the registration PDU session in the 5G, in the LT, that is known as PDU session. PDU session setup is known as the attach procedure. PDU session procedure in the 5G, but in the 4G it is known as the PDN attach, PDN connectivity. Attach, not a PDN connectivity, sorry. Attach is a registration procedure, and PDN connectivity is a video session setup. Right, there are two messages in the LT, but here only in the RRC setup complete message there is only one message for the only the registration purpose, information for AMF selection. And some quiz is there. If you have any question up to this RRC connection setup, you can ask. Now my audio is okay, na?
Yes, Sandeep. Yes.
Okay. If you have any question regarding RRC connection setup, 3-step RRC connection setup procedure and 4-step random access procedure, then you can ask. Then we will move towards the quiz.
ये 4 step.
Number of steps method used in the random access procedure is the 4-step. That is the correct answer. Number of message flow between the UV and G node B in the RRC connection setup.
3, sir.
3 message. Last message is for the registration message. There is registration with the AMF. And this is the N1 interface used in the 5G instead of non-SS setup. True or false?
True, sir.
True. Correct. That is message is the true. So we move with the 5G NSA operation. So 5G non-standalone operation is very similar to the 4G operation. 4G EPS, 4G actually in the 4G, the PDU session in the 5G, in the 4G it is known as the EPS bearer, attached procedure is there in, not attached procedure, sorry, the PDN connection is there in the 4G, and the PDN with the PDN connection, and in the 5G there is a EPS bearer is there in the NSA mode. The same, everything is same in the LT 4G and the 5G NSA. The same EPS bearer is also the connection between the UE and data network, that is the EPS bearer. Is also known as EPS bearer in 5G NSA. But what is the difference in the 5G NSA and 4G? You can see here S1U bearer and here is the S5 bearer or S8 bearer. Here, what is the difference in the 5G NSA EPS bearer and 4G EPS bearer? In the core side, the name is the same, but in the radio access side, the data radio bearer is changed. Name is changed. The 3 types of data bearer is there. Radio data bearer, RBG. That is the MCG bearer, SCG bearer, and split bearer. And all the other name in the process of setup a traffic between the UE and 4G core network is very similar to the 4G. The radio, when we have said the MCG bearer, when we have said SCG bearer, when we have said split bearer. When the data actually transmitted, there are one more thing, that is the master E node B. That is the anchor. That is the 4G E node B, 4G base station. This one is the secondary node. That is the SG node B. Secondary node, master node, always they have the control and data connection. Master node B, they have the, with the 5G UE, they both have control and data connection, but 5G base station have only the data connection with the 5G UE and towards also the 4G core. These are the 2 connections is there, right? This connection and this connection. are additional connection in the 5G NSA. In the 5G NSA, we have discussed three steps. First one is the 4G connection. They have already in the 4G. And second, the addition of the 5G base station. And third one is the addition of the 4G core with the G node. Okay. And this radio bearer is termed as three types of radio bearer. That is the MCG bearer. That is the master cell group bearer. When the data is moving from the core network, 4G core network is known as the EPC, Evolved Packet Core. Okay. When the packets come from EPC to master eNode B, and then data radio bearer is formed between them only, then it is known as the MCG bearer. And when then the data comes from the EPC here towards this G node B only, then it is known as this data radio bearer is known as the secondary cell group bearer. And third one is the split bearer. Split bearer is also two types. MCG split bearer, master cell group split bearer, and secondary cell group split bearer. When the data is split from the master eNode B towards the secondary eNode B, it is known as the MCG split bearer. When data comes from the core network to the base station and split at the secondary eNode B, then it is known as the SCG split bearer. So these are the some nomenclature that we use: MCG bearer, SCG bearer, split bearer, and master eNode B and secondary G node B is there, right? And this types of, actually this is a 5G NSA option 3X. This is also known as the ENDC operation. What is ENDC? ENDC means E stands for E stands for E ultra, means 4G radio, and N stands for new radio, 5G radio, and DC stands for dual connectivity. Whenever the master node is E node B 4G radio, that is known as the first number tells us the E is a master node, and second one N is the second letter, that is the secondary node. E means E ultra, that is the 4G node, and N means new radio, that is the 5G node, that is the secondary. E node, EN, DC. DC means dual connectivity. Dual connectivity means the UE is capable to receiving data from two scheduler, from the E node B also and G node B also. That capability should be there towards the UE. That's why they only use the ENDC operation. Otherwise, the UE will not be able to use that operation, 5G NSA mode operation. Right? Before adding the
Sir,
5G, yes, please.
This is which release, sir? This belongs to which release?
Which release? Actually, this belongs to 3GPP release 15. 5G NSA mode actually belongs to the, that is specified in the 3GPP release 15. Okay, sir?
Yes, sir.
Okay. Actually, this NSA mode, this non-standalone deployment option mode, that is the intermediate stage between 4G and 5G. It is a faster deployment option because we have 4G core, not BSNL have, but all other operator having 4G core, and they want to deploy their 5G. They easily can add the 5G base station at the radio side and some software upgradation. They can easily deploy the 5G network. That is the cost-effective and faster deployment option. But what is the disadvantage? What is?
Sir, one question is that SGNB, 5GNB, the secondary one that node station.
Secondary one is the SGNG. S means secondary. G node B is the name of the base station. Only S means secondary.
S
S
or
means
5?
secondary. Yes. Pardon, sir, kya?
But one note it down 4. That serial number 4, that 5GNB add. It has been mentioned.
4.
For this between MENB and SGNB.
This one is the X2. Actually, this is the X2. There is an interface between
this left one.
This one,
5G
node B.
add. 5G node B. But here in the lower side, it has written that SGNB. Is there any difference, SGNB and 5GNB?
No, there is no difference. Actually, 1, 2, 3, 4, 5. This is write a message how the secondary G node be add in the 5G NSA mode. Both are the same. SG node be here and here. They are secondary node in the NSA deployment option. The 5 step is here, na? It is just so only the how to we add 5G base station in the 4G core network. Right, sir?
That is SGNB is nothing but that 5GNB. The same SGNB can be converted to 5G.
Same 5G node B. SG node B just here is the prefix, na? S is known as the secondary. G node B used as a secondary.
Okay.
There is no RRC. Secondary means there is no RRC connection set up between the 5G UE and this 5G base station.
Sir, in this case of the NSA mode, the increase in the download will be whatever is being provided by LT connection plus whatever could be provided through 5G NR, right, sir?
Right.
And that too will be, and sir, that too will be limited by the capability of the core of 4G.
Capability of the phone, na? 5G phone.
Core network, sir. Core network, 4G core network, EPC.
Yeah, capability core is actually very much capable to provide the data. Actually, the main bottleneck is at the radio interface side.
Okay.
Right, sir?
Okay, sir.
Okay. Only in the NSA deployment option, actually, na, only one slice we can say 3GPP slice, that is the enhanced mobile broadband. It supports 5G NSA mode, supports only one 3GPP slice, that is the enhanced mobile broadband. All other slice like low latency application, URLLC and MMTC is not supported in the NSA mode. That is the drawback of this 5G NSA. Only one enhanced mobile broadband slice is supported by the NSA, 5G NSA.
And probably that is the need of the common user, sir. Majority of us. Majority
of us. What is the need?
No, sir. Yes, I'm telling you that is the common need of the majority of the customer, because they want EMBB. Latency.
Latency application is used in other application, right? Yes, sir. Very correct, sir.
Okay, sir. Thank you.
Now, in the NSA mode, before secondary G node B addition in the RAN side and the connection between G node B to the EPC in the core network side, before that there is already LT connection 4G EPS bearer setup is already there. So how first 4G EPS bearer will be set up? We will see here in the 6th step, or further next the 6th slide is there. Similar types of UE acquire the network. Just I have discussed downlink synchronization, then uplink synchronization. Then second step is the signaling connection between them, RRC connection setup. Right. Second step is the UE gets the signaling connection, means RRC connection setup between the UE and E node B. Right. Third step is the UE request for attach. Attach is the similar to registration request in the 5G. Attach is very similar to registration request in the 5G, but in this attach request, the PDN connection request is also there in the 4G, whereas in the 5G, in the UE request for registration only, the PDU session request, establishment request is done separately. They are not default PDN connection is there in the 5G. Fourth step is the after the sending the registration request, there is authentication between UE and core network. And in the fifth step, UE gets the IP connectivity. The IP connectivity means EPS bearer. There is a set of path between UE and the core network as S5, S8 bearer and S1U bearer and data radio bearer. That is the whole path is created to transfer the data. Right, in the system, you will request a service or dedicated bearer, you can say. The few slides are just a basic of the LT core setup, how they are connect with the UE with the core network of the 4G. First, UE acquires the network. Where is the some questions, how the UE ask with the network, where am I and how is the network sending me information, which network I want to read, and do I know what the network is capable of. All this question of answer is for the acquiring the network. UE wants to acquire the network when they are first switch on their mobile. So same thing, just I have already discussed now. Downlink synchronization and uplink synchronization, right? And cell selection. And after downlink and uplink synchronization, second step is the UE gets the signaling connection. Signaling connection means RRC connection setup between the UE and G node B, E node B. Sorry, here is this is the 4G, that is the evolved node B. And after RRC connection setup, there is a temporary ID given to the UE by E node B. Here, this one is your temporary ID. What is the name of temporary ID? Cell radio network temporary ID, CRNTI. That temporary ID used for further communication from the base station to the UE. Right. And third step is the UE send the attach request. UE send the attach request. If you compare with the 5G, that is the registration request. And fourth step to connection between UE and core network, that is the UE gets authenticated. That is authentication is done. It is a mutual authentication. Mutual authentication means both are authenticating the network. That means the UE is also authenticating the network and core network is also authenticating the UE. Both way authentication is there. Who are you? This is me, that UE side, and who are you? This is me from the core network side. Both are mutually agree are authenticated. After authentication, there are some key exchanges from core network to the UE for the security mode command, integrity and cipher key, like that. And fifth steps, it's the UE gets the IP connectivity, or you can say PDN gateway is there that provides the IP address to the UE, and the default EPS bearer. This one is the default radio bearer and default this one. This one is the default radio bearer, and here is the S1U bearer and S5U bearer is there with the core network. And this whole bearer is known as the EPS bearer. And each EPS bearer having the unique QCI in the 5G quality of service, that is the QCI, that is based on the EPS bearer base. Right, that is default EPS bearer is created in the attached message in the 4G network. In the attached message in the 4G network. And step 6, when UE requests a service, UE requests a service means UE wants to a dedicated radio bearer, dedicated EPS bearer. Other than default, more than one bearer can be connect with the UE and EPC. First one is the at the time of attach, there is a default bearer that is created, EPS bearer. After the creating that default bearer, EPS bearer, if UE want to request the dedicated bearer with the some other QCI, right? And the default bearer, actually they are giving the QCI 9 or 8 like that, which are the non-guaranteed GBR. Non-GBR, that means non-guaranteed bit rate type of QCI. So that's why this 6 steps actually is shown the UE 5G, or you can say ENDC capable UE connect with the 4G core network. They have already 4G core network connected, that is connected by which UE? That is the ENDC capable UE. And after the ENDC capable UE, if they want to, they have already the EPS bearer, na, default or dedicated bearer. If they want to add an G node B, so what is the procedure of adding the G node B in their radio access network? Right. The first one is the signaling, RRC signaling connection is always there. RRC signaling connection is always there, is the 4G node B. Then this one is already there, na? Then this first, the 4G node B inquiry to the 5G. That is the capability inquiry. Whether it is a capable UE is there. That is the ENDC capable is UE is there or not. That capability inquiry information contains the what frequency band they are capable, what MIMO layers they are capable, what subcarrier spacing they are capable to transmit. All this capability inquiry is done by 4G node B, that is the master node B in the 5G NSA mode. After the measuring the capability, the 5G send the measures. 5G phone sends the request to measure the 5G cells. Actually, this arrow is this side. G node, E node, we send the measure the 5G cell, right? And after measuring and detecting the NR cell by the 5G UE, this. After measuring the RSRP, SSRSRP by the 5G UE, they send the measurement report. They send the measurement report to master node, 4G node B, to take the decision to add 5G. To take the decision on the 5G. And this one slide shows after the RRC connection, right? 5G measurements, 5G measurement, actually 5G measurement. What measurement? RSRP, SSRSRP, RSRP. SSRSRP sent in this measurement, the actually 4G node we have a B1 event is there for addition of G node B, that having the threshold, how much threshold is having, that is beyond the SSRP of that threshold. If they are beyond the threshold, it takes the decision to add the 5G G node B. Who takes the decision? The master E node B take the decision. After taking the decision, add to G node B, the master E node B send the addition request to the 5G secondary node, by the on which X2 interface, on the X2 interface. Okay, here in this X2 interface. After taking decision, if the SSRSRP is the above the B1 threshold, that is B1 threshold is used for the addition of the G node B, then it sends this request to G node B, and then G node B take the admission call and send the acknowledgement on the X2 interface, to the master E node B, right? What is the acknowledgement message? It contains the their frequency band capable and all the other 5G base station capability, like the what is the initial bandwidth parts where they are sending the message, and all the other parameter like A1 parameter that all of you have know, the different bandwidth parameter. They send the master E node B, and all this message are sent to the UE by RRC reconfiguration message. Sent to the UE on the control channel by dedicated control channel by RRC connection reconfiguration to add this 5G cell. And this UE side, they send the message like RRC connection reconfiguration complete. That means he know all the message that contains the RAG parameter message, everything message that have sent by the G node B to the on the X2 interface, and then it receives on the RRC reconfiguration message. It's in the RRC reconfiguration complete, and this message transfer to the 5G G node B, and after the successful reconfiguration, they access to G node B. 5G UE now access the G node B by what? By RAG procedure. Synchronization is always there with the 5G G node B, but RRC connection setup is only with the 5G UE and master E node. RAG is also is signaling, but this is not a permanent connection between the UE and 5G G node B. That's why the NSA 3X is known as the connection is UE and G node B, E node B, and E node B to core network, like that.
Sir, one question, sir.
Please.
Sir, in this case, I think 4G UE also can be used with better performance in 5G, like
Right.
5G.
Right.
Oh.
Better performance than 5G. Actually, why we add G node B in the 4G RAN? Because to give more and more data to the UE, 5G UE, ENDC capable UE, so that there are two scheduler, and if they are ENDC mode, dual connectivity mode, the 4G base station is also sending the data, and 5G base station is also sending the data to the UE to enhance the throughput only.
Sir, one hypothetical question, sir.
Yes, sir, please.
Sir, suppose I have got a pure 5G mobile handset, doesn't support 4G LTE, so it can't be used in NSA mode. Have I understood it correctly, sir?
Pure 5G means
it has got only 5G, no 4G.
Pure 5G means they are not able to connect with the 4G node.
Yes.
You want to say like that?
Yeah.
But 5G always 5G is standards make in such a way that it always backward compatible.
That's true, sir. It's a hypothetical question only. Suppose I acquire a 5G headset which has got only 5G and not having 4G LTE, so it can't be connected in NSA network. Have I understood correctly, sir?
Yes, sir. Yes, sir. I understood your question. Actually, you want to say if ENDC capable UE is there, it's different UE, and 5G capable UE is different UE. You want to say like that?
Yes.
But if ENDC capable UE is there, that means there are already 5G capable UE. The dual connectivity is a concept of scheduling from two base stations. Dual connectivity is not the only in the NSA mode. Dual connectivity concept is also used in the 5G, pure 5G network, standalone deployment 5G, where 2G node B are connected.
Okay.
To improve the handover performance, to improve the zero interruption time during the mobility from one base station to another base station.
Okay, sir.
Okay, sir.
Okay, sir. Thank you, sir.
Okay. Now that is the G node B added in the 4G RAN. Now the addition of G node B with the EPC. EPC means 4G core. This one first one you see here, na? The data connection between the E node B and 5G capable UE and E node B to the core network is already set up. That I have already discussed, na? So after when the RAN is added 5G G node B, 4G RAN is added 5G G node B, and the core networks begins to forwarding the packet forwarding. E node B till time they are forwarding the packet by E node B. But now there is a need of modification the S1U bearer. S1U bearer, so that the connection between now the data move from the serving gateway to the 5G node B and 5G node B to the UE side. SCG bearer. How we concept? First, you have to connect serving gateway to the 5G node B. How they connect? Actually, previously they are connected. Serving gateway are connected with the 4G node B. If data wants to move to the secondary node B, the connection should be there between the serving gateway and 5G G node B, for which they are sending the 4G E node B, sending the data bearer modification indication. Right? Data bearer modification indication. And the serving gateway send the bearer modification S1U bearer modification indication is there. Send and request the both message there. This message is MME send the message to the serving gateway, and serving gateway then send the message to the MME, and MME send to the master E node B for data bearer modification confirmation. That means now end of the packet forwarding and the connection setup, already connection setup be there. This data bearer modification confirmation, that means it have the message of the different tunnel ID, different tunnel ID between the G node B to the serving gateway, all the information carrying this message actually. And they created this data path between serving gateway and G node B. And this G node B now transferring the message towards the 5G UE, 5G capable or ENDC UE. And these types of transmission of data is known as the SCG bearer, because we are sending only the from the G node B data. But if there is a split, data want to move from 4G node B as well as G node B, then there is a split, data split from here. G node B, some data move towards the 4G node B and 4G transfer the message, and some data move directly towards the 5G UE. That is known as the split bearer, that SCG split bearer, SCG split bearer. So these types of modification is done in the core side and radio side for the deployment of 5G and SM.
Sir, what is SCG?
SCG is the secondary cell group bearer. Actually, your all the EPS bearer is the same in the 4G data connection, PDN connection, and also in the 5G NSA connection. The name of the connectivity is the same. PDN connection is the same like EPS bearer. Right, sir? But the radio bearer, data radio bearer, DRB, that is connected between the 5G UE and the 4G E node B and 5G UE and 5G G node B. That is the name is different. That is the SCG. That is the data radio bearer that is connected between the 5G G node B to the UE, and MCG, that is the data radio bearer when they are transmitting only from the 4G E node B to the 5G UE, that is the MCG. Yeah. When they are splitting, then MCG split and SCG split.
Okay. Okay, thank you.
Okay, sir. Now I am going towards the 5G standalone call flow. Now, any question from NSA mode? 5G non-standalone deployment mode call flow. It is just a basic call flow. I will not go in the detail of the messaging. Now, what are the message between all the bearer modification and all other things? Just an overview of 5G NSA mode. And if there is any question, then please ask. Then we will move towards the 5G SA call.
Difference between sir split master and split secondary GC.
There are three types of data radio bearer, DRB. That is DRB
Yes.
between the UE and RAN. Understood,
Yes,
sir?
Yes.
So
Yes.
three types of data radio bearer. First one is the MCG data radio bearer. MCG, right?
Yes. It's correct, sir. I want to know split.
MCG means data radio bearer only between the UE and 4G E node B. That is the MCG.
Yes.
Is simply your EPS bearer is the same, but your data bearer name is just nomenclature in the NSA mode. Your data bearer name is changed just like a MCG. In the case of data radio bearer with yes, sir.
Sir, split mode has two parts, sir. You told, sir.
Two things is there. First thing is the dedicatedly data radio bearer is set up between the UE and 4G E node B and UE and
Hello. Hello.
1 minute. Hello.
Sir, voice breaking, sir.
Okay. Actually, I connected my PC laptop with the phone hotspot. One call is come, then it all directly. Then 5 MCG means your data bearer that is connected between UE and E node B.
Yes.
That is the when data only transfer from the 4G node B, then the data radio bearer is known as the MCG.
Yes.
When data your move from core network 4G core network toward the 5G G node B and move towards the, let me draw. No, actually drawing is very difficult on mouse.
Yes, that I understand, sir. That I understand.
MCG and split. You want to ask regarding split bearer?
Yeah, split bearer means you have told that two parties there, sir. Master split and
having split bearer means two types of split bearer. One is the MCG split bearer, na? MCG split bearer. Second one is the split. Second one is the SCG split bearer.
Yes.
Correct, sir?
Yes.
When the packets come at the G node B, right? And from that location, when split is there, that means from that PDCP split is there in the E and DC mode from the PDCP level in the NR. There are different protocols layer is there, physical layer, MAC layer, RLC layer. On the top of RLC, that is the PDCP layer. So data split happens at the PDCP layer. When the data split happens at the PDCP layer of G node B, that is known as the SCG split bearer.
Yes.
When the data split is happened between at the E node B side, at the PDCP layer, it is known as the MCG split bearer.
Okay, sir. Okay.
Only the nomenclature is there, sir.
Okay.
Otherwise, everything is same. Whole pipe is known as the EPC bearer, EPS bearer. But at the radio side, they change the name of DRB, MCG bearer, SCG bearer, and MCG split bearer and SCG split bearer.
Okay, sir.
Correct, sir?
Yes.
Okay,
Thank you, sir.
Now we are moving towards the 5G standalone call flow. This slide showing just a brief overview. You have already very much study regarding this core network, 5G core and 5G RAN. It is just a overview how they are connected. Actually, the two G node B are connected with the action interface, right? There are different network functions, AMF, SMF, UPF, PCF, right? There are different interface, na? N1, N2, N3, N4. And some of the interfaces, service-based interface is used in the core network, na? In the control plane. All this interface is known as the service-based interface. SBI interface. Here. No, the common protocol is there, and the HTTP2 protocol is used between the communication between these network functions in the control plane. In 5G, the control plane and user planes are totally separated. Na? Control plane functionality and user plane functionality is totally separated. When user planes in the 5G network, na, there are both types of currently both type of interfaces there. One is the service-based interface present in the core network control plane core network of the 5G, and another one is the reference interface like the N1, N2, N3, and N4. These are the four interface that connects the user plane to control plane. N1 is for the control plane, that is the between UE and AMF, right? And N2 is between the G node B to the AMF. That means here, this is the G node B and AMF. And next one, the reference point interface is the N3 between this UPF and G node B, and N4 is between UPF to SMF. That is the N4. These four interfaces is important, N1, N2, N3, N4, that is used in our call flow actually, right? And another interface is the SBI interface, service-based interface. Need not to discuss the service-based interface. This slide shows some of the identifier that is used in the 5G. Identifier you have already know, but just 1 or 2 minutes we have discussed here. Some permanent now the in the 5G.
Please, sir,
Yeah.
sir, one question, sir. In previous
Yes, sir,
slide, you
please.
told that N1 interface between UE and AMF.
Right.
So that is the air interface.
Not just here. It is actually 5G is not for only the 3GPP radio. It may be 3GPP radio. It may be other Wi-Fi or other network. So that one additional interface is defined in the N1. I think so. One additional N1 interface is known as a NAS interface. Just a nomenclature. It can be N1 interface, may be used for the non-3GPP radio, or maybe 3GPP radio, 4G radio, yeah, or 5G radio. It may connect user interface side UE to G node B, then G node B to the AMF. There is another connectivity. But for the non-3GPP radio,
that N1 in from G node B to
N1 is just a
AMF.
logical connection, sir. N1 is just a logical connection. It is not any wired connection or any direct connectivity between UE to AMF. There should be an interface or in between them to communicate with the AMF.
Okay.
Whether it is a 3GPP or non-3GPP. Okay,
That
sir?
means that involves that in between UE and AMF,
yeah,
that G node B is also there.
Yes, sir.
For N1 connectivity.
Right, sir.
Logical
Right.
connectivity.
N1 is just a logical interface name of NAS.
Okay.
Okay, sir. So just 3 types of identifier used in the 5G network. That is the user equipment. Previously, up to 4G, that is IMEI. All of you know the International Mobile Equipment Identifier. But now in the 5G, the equipment is not only mobile. It could be many things. It could be the phone, or it could be a car, it could be sensor, it could be anything, it could be robots, it could be any machines. So that the another one identifier is used for the equipment identity, that is the PEI, that is known as the permanent equipment identifier. Another other identifier is also used for the non-3GPP equipment identifier. 5G also capable to communicate those equipment. And some subscription identifier, that is the MSISDN, already know you the telephone number. And another one is the GPSI, General Public Subscriber ID, is used in the 5G network in the place of MSISDN. This is the public one. It is this GPSI or MSISDN used for the public, not for the network. Network is never communicate with this MSISDN. Network is always communicated with the in the 3G or 4G MC, but in the 5G it is communicate with the SUKI or another temporary ID, that is the 5G TMC or 5G GUTI. Public ID is only for the sake of communication between the users. And private identity, that the SUPI, that is the permanent. All of you know, I think, SUPI, subscription permanent identifier, and the subscriptions of temporary identifier, that is the SUKI. Then they never, UE never transmit the permanent identifier at the air interface. They have already concealed this message and then sent to the AMF or G node B. And some other identifier, temporary identifier, that is the 5G TMC and 5G GUTI. And the network function identifier, one of the network identifier that is used as the GOMI. GOMI is the identification to the AMF. This is the identifier of the AMF, a globally unique AMF identifier. That is the network identifier. And what GUTI basically contains, that is, it contains the PLMN ID. All of you know the PLMN ID, that is the MCC plus MNC. Then after PLMN ID, it is a AMF region ID. If you compare from the LT, it is a MME pool ID. Just like a MME pool ID, there is a AMF region ID. And then AMF set ID. This is the new addition for the slicing set. AMF set ID is the set of slice, actually AMF that the UE subscribed. That is the for the AMF set ID. And AMF pointer is just a MME code that is used in the LT. MME code that is used essentially, that is known as the AMF pointer. And all we combine all of them, that is known as the GOMI. That is the globally unique AMF identifier, that identified uniquely to the AMF. Right? And what is 5G GUTI? GUTI is a combination of this GOMI plus 5G TMC. Okay. You have seen in the previous slide, the paging is done on the basis of 5G TMC, not by the 5G GUTI, because 5G GUTI is a bigger message. The 5G TMC is a shortened form of 5G GUTI, so that the paging capacity can be increased at the radio interface side. This can to the right, sir?
Yes, sir.
Okay. Now the just like a attach message in the 4G network, attach procedure is the mobility management procedure in the mobility management procedures of 4G, that is the attach. But here in the 5G, that is known as the registration procedure. how the network register in the 5G core network. Registration is always happen in the AMF only. Registration, any UE is registered or not registered, that information only who contains the AMF only. The registration information of UE are stored in the access and mobility management functions. Right? And what are the procedures? First, we will discuss in the call flow diagram. Just in this view, we have the subscription identification UE sent to the G node B, just like RRC setup complete message. RRC setup complete message. There is a subscriber identity, SUKI or 5G GUTI is there for the registration request, and this registration request sent to the AMF. Right. After sending the AMF, they establish the security between the core network and UE mutual authentication, and then security mode command. They provide the key for integrity and ciphering key. Right. After the policy check means mobility management regarding policy, they check with the PCF. And after the checking the PCF, they are authorized to register AMF, allot the temporary ID allocation. That is the 5G GUTI. 5G GUTI, they allot to the UE on the NAS message. Right. So this one is the concept, the AMF, how the AMF register the UE and store the registration information in the AMF. They communicate with the UDM for the security purpose, for the authentication purpose. They communicate with the PCF for policy check, and they send the GUTI in the registration complete message. This is your GUTI and this is your registration area. If you want to further any communicate with the AMF, they just send the 5G GUTI or 5G TMC, not the SUKI or SUPI. SUPI is never transmitted on the network side, but then they always transmit the SUKI message, concealed message.
Sir, who sends GUTI, sir? Who sends GUTI?
Who sends GUTI? AMF sends GUTI. AMF sends.
Okay,
who does the registration? Who does the registration?
AMF
does
sir.
the registration. AMF. That's why AMF sends the GUTI message to the UE. All the communication from UDM, PCF, AMF does the communication to authenticate, and PCF for policy, mobility management policy related function. Then they allot the GUTI in the message of registration complete message.
Sir, one question. So,
yes,
what is the difference between SUKI and GUTI?
SUPI is the permanent identifier, subscriber permanent identifier. At the
no,
air
sir,
interface
SUKI,
side.
SUCI. Sir, last slide is
SUCI is the concealed identity. You use SUPI is first convert to conceal, means you encrypt the SUPI in the such way so that the at the air interface side no one catch the your permanent ID and make a fake ID.
what is GUTI, sir? What is GUTI? So then what is GUTI?
GUTI is the temporary ID that is allotted by the AMF after the registration. GUTI is a temporary ID of the UE that is sent to the UE by the AMF after the registration complete message.
So that means before registration that SUKI is transferred. SUKI message is
SUKI is transmitted. Yes, before
so after registration then.
Well, 100% correct, sir. 100% correct.
So when TIMC is only during the paging time.
TIMC.
TIMC.
5G TIMC.
Yeah.
5G TIMC is a shortened form of 5G GUTI. For the improving and increasing the capacity of the capacity at the radio interface side, they are send the 5G GUTI instead of 5G TIMC instead of 5G GUTI. for enhancing the paging capacity, not other than that. Okay, sir?
Okay.
Okay. And this network registration, we can see here in the form of call flow diagram like that. First is the registration request, either by sent by Suki or either we send by Suki or 5G Guti. The Suki is when your mobile first time switch on, then the Suki. Okay, this is the concealed identity, and who anyone who deconceal the Suki in the core network, that is the UDM. UDM is responsible for the deconceal the Suki so that he know the who is the user. What is the Supi? Supi is stored in the UDM as well as in the UE side. Okay. The registration request is sent in which message? In the RRC setup complete message. RRC setup complete. If we see in the RRC connection setup, na RRC setup complete message. I am writing from the mouse now on this slide. Write this setup complete message. Okay. After sending the UE sent to G node B this for the registration request. So who does the registration? AMF does the registration. AMF, SSN mobility management function. So G node B selects the AMF. Actually, 5G supports the network slicing function. There are many logical networks, so that the different AMF for different logical functions, different network slicing. So there is another subscription identity that is known as the NSSAI, Network Slicing Selection Assistant Identifier. That is also sent with the registration request. If this UE G node will select the AMF based on this NSSAI, Network Slicing Selection Assistant Identifier, or by using the default AMF. They select the AMF and send this message that is sent by the UE to the G node B. They forward this message to the AMF, and then AMF select the AUSF. Why AUSF select? AUSF is responsible for authentication. Authentication in our 4G network, the authentication is given by the MME. But here is 5G. There is a two level of authentication. One is done by the AMF, another one is by the AUSF. But the final authentication is done by authentication is only by the AUSF. The AMF is only for the serving network, and AUSF is responsible for home network. AUSF authentication for the home network, and AMF is the for the serving network. That means AMF may be from the home network or maybe from the some other PLMN or roaming network. So that there is a two level of authentication is there in the 5G. First one is the AMF level authentication. Second one is the AUSF level authentication. And final authentication is based on the AUSF home network AUSF level. That's why AUSF is selection is there. They are never select the AUSF of the foreign network. They always select the AUSF of the home network only for the authentication, permanent or final authentication. Then there are different algorithm, ACA algorithm, 5G ACA algorithm is there, by which the users are authenticate and network is also authenticate. Right? The authentication and security procedure is there in between UE and network, and deconceal of this Suki is done by the UDM. Deconcealment is done by the UDM, and all the security mode command and everything, authentication is done, and in the fifth process. After that, the AMF, you can see everything is done by the AMF, whether it is a AUSF selection, right, or UDM selection or PCF selection. All these are selection is done by the NRF. NRF, one of the network functions, repository functions, where with the help NRF facilitate to select the UDM and PCF, right? All the network functions, what services they are provided, all registered here in the NRF. That's why NRF facilitate to AMF to select the proper UDM and PCF, because in the 5G network there is more than one UDM and more than one PCF is there. So for UDM, they select the UDM, AMF select the UDM for what purpose? For the registration and retrieval of the SS and mobility subscription data for the whether the UE is subscribed for the 3GPP EMBB slice or URLLC slice, on whether it is allowed to register in this registration area or not. All this mobility subscription data are fetched from the UDM by the AMF selecting the UDM. After the getting the data, network slicing data, what they subscribed, what they are allowed in the registration area network or not, all these things are they get from the UDM. And after getting these data, they select the PCF for what purpose? For the mobility management policy query. Mobility management. AMF is only responsible for the mobility management, na? SS and mobility management functions. So PCF query is for the mobility management policy rules. They ask to the PCF and they get the policy regarding of the mobility management, registration, attach, or everything. Na? They get the policy and they send the registration accept message. Registration accept message to the UE. In that registration accept, there is a information that is the 5G GOTI, and also there is a registration area. Registration area, if we compare from the 4G, it is a MME pool, like that MME pool ID, you can say. MME pool ID is there. Group of tracking area ID, na? Group of MME ID is known as the MME pool ID. So there is a two things. When the UE move from one registration area or other registration area, the registration request initiate from the UE. One initiation registration request initiation from the UE when the UE enter from one RA to another RA. Second initiation is when the first time UE on their phone, that is the initiation of registration request by the UE. And third one is the periodic registration area. Periodic registration area, it based on the timer that is known as in the 5G, that is the T3512 timer, just right now T3512 timer. That periodical registration area update is initiated by the AMF only, so that the current location, he update their current location of UE in that AMF. And after this registration accept message, UE send the to AMF the registration complete message. This is the NAS message. Na? NAS message is sent on the SRB2 radio bearer at the radio interface side. This is the registration process in the 5G. They are totally different from the 4G. Now, after the registration, there is a PDU session establishment for the user traffic transfer from the UE to the DNN or in the network. Any question from the registration procedure of the 5G?
Excuse me, sir.
Sir, little detail
please.
about 5
Excuse me,
5321.
excuse me, sir.
5G. Yes, sir, please.
Sir, one side slide back, sir. Back slide.
Back side.
Registration.
Okay. Yeah.
Sir, there's second. The second, sir.
Second step.
Yeah, second step, selection of AMF. Who initiate and who decide the AMF? First time.
Selection of AMF is done on the actually G node B. G node B select the AMF based on the which information NSSAI, Network Slicing Selection Assistant Identifier, that is sent by the UE to the G node B. On the basis of that, they select the AMF because different AMF is there, different they are in the different network, logical network. So that or different actually if NSSI is not giving the proper information, then the G node B select the default AMF. There is a default AMF is also there.
Sir, in case of roaming, sir, how
Roaming.
Roaming,
Yes,
sir.
yes. Roaming.
How G node B will know the that NSSI is how it will know the this belong to which home HPLM?
Actually, if there is a roaming agreement between if the network latch from the roamer, if one operator or one LSA, you can say national.
Yes.
You want to ask about national roaming or international roaming?
Whatever,
National
sir.
roaming.
Yeah.
National roaming. So there is a PLMN identity which they actually accept. PLMN identity preferred list. PLMN identity is there in the message, SIP1 message in the 5G.
Yes.
And after the PLMN identity, they select the network.
Sir, but that information is not available in G node B, sir. That may be available in EMF.
Actually, PLMN identity that is sent by G node B, this send the actually what are the roaming actually in the roaming scenario? Suppose a Punjab users goes into the UPs, suppose in the LSA. Okay. So in that LSA, they are actually switch on their phone. They latch via this their PLMN ID. That PLMN ID actually accept by the AMF. That is our other user. Roamer is there. That is agreement between both of the network. That is this type of MCC plus MNC. We can accept and authenticate that users.
Okay, sir. It means, sir, the G node B by default select the MF default MF.
They may select the by default, or they may select by using by saying this network slicing assistant identifier.
Okay, sir. NSSI is given by the UE.
Given by the UE at the time of registration request. And NSSI is a list of slicing networks that UE subscribe actually. Different slice UE can subscribe. That is the list of network slicing that subscribe by the UE. Okay, sir. Now the PDU session establishment. Okay, sir. Now the PDU session establishment. Who is the responsible for the PDU session? AMF or SMF? SMF. SMF is responsible for the PDU session establishment. This one. Right? So in the PDU session establishment request, UE after the registration accept complete, they send in this complete message that is the PDU session establishment request. There are three types of PDU session request. First one is the IP version 4 or IP version 6 or dual stack. That is the IP types of PDU session establishment. There are three types: IP type. Second one is the non-IP, like the your Ethernet type of packet data, non-IP. Third type of is the unstructured data in the small data scenario, na, some type of in the smart home and all other applications, na, smart city, some of the unstructured data is also transmitted in the network by different of types of the equipment. Okay, so they send these types of, whether they want to connect with the IP connectivity or non-IP or unstructured. They send in their request via G-Node B. This is sent on the NAS interface, N1 interface. It is a logical interface actually. And after sending the PDU session establishment request, what it does, it actually select the SMF. There are many SMF depending on the network slicing, right? Networks, there are different network slicing, not different. There are many logical network on the top of one physical network. That's why there are many network functions for different network slice. So SMF selection is done by the AMF because AMF wants to communicate with the SMF who is responsible for the PDU session establishment. So they select the SMF by using the slicing and by using the NRF. With the help of NRF network repository functions, they facilitate to select the SMF, right? And then the create the session management context. What is the session management context? There are different contexts. There are UE contacts and initial UE contacts as create session management contacts. It is also similar to UE contacts, that is for the session creation purpose. For the session creation purpose, and if SMF get the PDU session request from the UE, then the SMF again asks with the PCF. Ask with the PCF for the session management recording policy. What is the session management recording policy? With whether
Sandeep,
yes?
how many more slides here?
2-3 slides, sir. 2-3 slides more.
Okay, right. So it's about 1:30.
Okay, I
2
think more
p.m. also we
130
have.
is there. Okay,
Yeah,
I will finish in 5 to 10 minutes. 5 to 10 minutes.
As quick as possible
Okay.
because there is another session at 2. We have to give break also.
Okay, sir. Within 10 minutes, we will finish that. After selecting the PCF, they are getting the information, the policy regarding the session management, and then after the they ask and get the information, then they select SMF. Actually, select the UPF. There are many UPF in the 5G networks. UPF are actually not centralized, just like in our legacy network. The UPF are distributed for low latency applications. UPF are very near to the user at the base station side, and for the other application, they are at the centralized side. Okay, so they, on the basis of that, they select the UPF and they create the N4 session statement. This is the user plane and control plane functions interface N4. That is the PCFP protocol that is used between the SMF and UPF. They send all the policy charging rules and QS enforcement rules. This SMF sent to the UPF on this N4 interface. After the creating this message, they send the PDU session establishment accept and creating the N3 tunnel between G-Node B to the G-Node B to the EPF. Okay, and this send the PDU session accept response and update the session management context request and the on the N3 tunnel. Both way tunnel ID created between the G-Node B and UPF and hold the PDU session establishments had been done between the UE and your DNS. Okay. This slide I have skipped. These are the signaling message, how they transfer from the UE in downlink and uplink, right? you can this slide is also in the uploaded in the on the team. This one is the action handover, and okay. Action handover. What is the action handover? That is the interface between the 2G node B. Right. This is just how the handover between 1G node B to 2G node B happen when device move from one base station to other base station. The RSRP of the serving cell and neighboring cells are reported by triggering the event and sent to the G node B. And they coordinate, 2G node B is coordinating the handover performance on the action interface. Okay, and they request to switch the PDU session path from this node B to another node B. And this AMF sent to the message switching information to the SMF, and SMF is request switch the PDU path to the UPF, and then UPF create a tunnel between another G node B, this another target handover G node B created. Right, this is the 4-step process for the action handover. Right. I'm ending this session. By this, if any question you can ask, otherwise 1 or 2 question is there. After that, I will finish the session. Any question if you have, then.
Yeah, please go ahead, Sandeep.
Okay. Quiz is there. The periodic registration area update timer in 5G is a which one? A, B, C, D.
T3512.
3512. That's correct answer. T3512 timer. And bearer used in the 5G NSA 3X mode. Data
MCG.
bearer that is used. MCG bearer, SCG bearer, split bearer.
All of the above.
All of the above is the correct answer. And 5G GUTI provided by the AMF after the registration of the UE, after the PDU session establishment, after the RRC connection setup, and none of them. Which one is correct?
Registration of UE.
UE. Correct, sir. Correct. Thank you to all. Right, sir. If you don't have any question, then I think we stop this.
So Sandeep, it was a wonderful session which you took, and as you know that the topic which you covered is slightly complex, and maybe many of the participants would be feeling like it is some sort of a complex topic, but yes, you took in a very right way, in a very easy way, and I hope people have understood. Even if you have not understood, don't worry. You can refer to his PPT or his recording any point of time whenever you need that. So with this, thank you very much, Sandeep, for your session.
Thank you, sir, for giving me opportunity. Actually, thank you, sir.
Great. Maybe we'll work together on some more such initiatives.
Right, sir. We'll learn very much from you, sir. Thank you, sir.
Great.
So we stop sharing, sir?
Yes. And announcement for all other participants. The next session is at 2 p.m. So you have got only 25 minutes time for your lunch. So please do a quick lunch and join. Why 2 p.m. I cannot extend because the speaker has some other meeting and he would be joining at around 2 p.m. So I request everyone that kindly join by 2 p.m. again, or you keep the device connected and you can have your lunch. So thank you so much. Atul, if you want to say anything.
Just wanted to thank Mr. Sandeep Singh. He gave such a nice presentation on, as you mentioned, on a very complex subject of call flow for the SA and NSA configurations.